Hello students, I think you are doing well. Today we are going to continue unit heat and especially about specific heat capacity today. That is just continuity of this lesson. Before it you have studied about heat, heat and temperature and many other things. Today mainly we will discuss specific heat capacity and its effect in our daily life. There are a number of events which are based on specific heat capacity. So, we will discuss in detail about it. Okay. Before the lesson, we have to think one question. That question is directly related with the same fact about which we are going to study. That is, why are desert days very hot and desert nights very cold? We do not have desert in our country, but we should know about that fact that in deserts at day it is very hot, too hot. Yes, and at night it is too cold. Why not hotter at night? Yes, so here is some special thing, some special property that is found. It is due to some special property which is found in sand that is different from other places. Yes, so what is it? We will discuss today, don't worry. And here, to understand this fact, in some context you will be supported by the activity we are going to do. This activity is based on some figures and some questions. So, here are some figures shown. At first you observe each of the pair of figure. There are 4 pairs. In pair 1 there is steel plate and melamine plate. You can say plastic plate. In pair 2 there is wooden chair and next one is plastic chair. In third there is sand and soil. And pair 4 there is steel tumbler and a glass tumbler. So, your questions will be related with it, on the basis of which we have to think, we have to discuss. So, discuss on the basis of given pictures and following questions. Question number 1 is, which of each pair, that means out of these two, in each pair you have to think, heats faster when exposed for equal time in the sun. Consider all of them are exposed in the sun for equal time. You can say 5 minutes, 10 minutes, any time. After that, which one changes its temperature faster? That means which one heats faster. So, here are 2 plates. One is a steel plate, another one is melamine plate. Your guess. Okay, note down. Then in pair 2 there is plastic chair and here is wooden chair. Which of them? Like that, sand and soil both are in the form of heap, that is of equal volume, about equal volume of materials are taken. And here steel glass tumbler and what is steel tumbler and glass tumbler, 2 tumblers. So, in each pair you have to find out which one will be heated faster. So, it is shown that both are of about equal size but different material. They are also of equal size but different material, different colors. Here these two are of about same volume, yes, but in different colors, different materials. And here not only different materials but different size also. Yes. So, later we will discuss about it. At first you find out your thought, what do you think about them? Next question is, which of each pairs cools faster when left for same time inside? After that you have to cover them, you have to keep them on set, and for equal time you have to leave there. So, which one will be cooled? So, what do you think, that will they take same time to have same temperature or same time to cool faster, or that no one faster, no one later, both at the same time cool? What is your thought? If no, then what does the activity conclude? What does the activity shows? So, here you will get the gist that all the substances do not have same capacity of absorbing heat. They have different capacity of absorbing heat. They have different capacity of retaining heat in them. Not only absorbing, but retaining also. After absorption, Some substances can retain heat for longer time, and some substances get cooled faster because they cannot retain that heat. Is it? Okay. So here we are going to do next activity that is related with just you have to think and write, make a list of factors which affect on the absorption of heat. Also give an example for each factors mentioned. So here it is based on the knowledge of junior classes. In junior classes you have studied that what type of metals have more absorption of heat or which color absorbs more, whatever. More hint I will not give you, just you think what may be the factors which affect on what? Absorption of heat. Okay, at first note down. Okay, so I think you have mentioned color because already we have discussed about color, chairs color, sand and soil color. Yes, so color, dark or light. So I think you have done about it. Dark colors absorb more heat than light colors. That's why in winter, what colored clothes we prefer to wear? Yes, dark colored, blue, black, red, yes, like that. Dark colored cloths are preferred to wear in winter, and light colored fabrics are selected for what? Summer season. It is the region. Yes, you have done about it in class 7, 8, yeah. Now next one is exposed surface area. You have seen that people dry their grains, they spread it. Yes, they do not make heap only to dry them. The grains are scattered in the field. Scattered means that means spread. Yes, and we spread our cloths to dry. If you are not spreading, then what will happen? Will it dry sooner? No. So by absorbing heat, that has to dry. So more heat can be absorbed if the surface area, if the exposed surface area is greater. So that is more surface area, more exposed surface area absorbs more heat. Okay. Next one, nature of surface. What type of surface? The surface is smooth or rough. That also matters. Rough surfaces absorbs heat more. Rough surfaces absorb heat more, and smooth surfaces absorb less. Yes. Next, temperature of the body. So here at which temperature, that is less temperature, more temperature, here it is little bit difficult to understand here, but later when we will do experiments and we will read some more, you will be more clear about it, that the temperature of the body, or you can say here due to different capacity of absorbing, the substances have that means have changed their temperature. So that temperature may be more or less due to that absorbing capacity. Later we will discuss about it. Yeah. So there are some factors on which and another thing also you can understand, temperature of the body means from the body where it is getting heat. If it is at more temperature, then body can absorb what? Body can have what? More heat. That also you can understand. Yeah. Okay. Now here nature of substance, it is the main thing. All the substances do not have same retaining capacity of heat. They have different retaining capacity. Yes, major thing is that about which we will discuss here, and this retaining capacity is termed as what? Heat capacity as well as specific heat capacity. Both terms are not the same thing. They are different thing. Heat capacity is one thing, but related with it, there is another one, specific heat capacity. About molar heat capacity, we do not have to discuss. In fact, there are two types of heat capacity. Specific heat capacity, which is related with gram, and another one is molar specific heat capacity, which is related with what? Mole of substance. The amount of matter is measured in mole. So leave that molar heat capacity. We will discuss about specific heat capacity mainly. This is it. Okay, students. So at first we are going to discuss about heat capacity. Slightly different. Heat capacity and specific heat capacity are slightly different. What is heat capacity then? When you are heating any substance, doesn't matter what mass of it is, then what heat is required by the matter to raise its temperature by 1 degree Celsius. That is heat capacity of that substance. Yes. So, what is given in first point? Heat capacity is a measure of how much heat energy a substance can absorb or release without a significant change in temperature. So, there is mentioning 1 degree Celsius, not significant temperature, just 1 degree Celsius, not more. Yes. So, easily you can understand in this sentence also total amount of required heat to rise 1 degree Celsius or 1 Kelvin temperature of any matter. Remember, change in 1 degree Celsius is equivalent to change in 1 Kelvin. I am not saying that 1 degree Celsius equals 1 Kelvin. I am saying that the change in temperature in 1 degree Celsius is equivalent to the change in temperature is 1 Kelvin, because in both of the temperature scales, the gap in lower fixed point and upper fixed point is 100. Both have same range in between freezing point of water, or you can say melting point of ice, and boiling point of water at sea level. That is why you cannot say that difference in degree Celsius is equal to difference in Fahrenheit. No, in the case of Kelvin. So, although Kelvin is SI unit, we can use degree Celsius instead of that, and usually that is in use, that is in practice. Yes, okay. So, what is heat capacity? Remember one thing here, before it also we have discussed that C I am using as symbol of a specific heat capacity, which is globally accepted symbol. We are using yes also. So, if you are using yes, that is also okay in our context. Specific heat capacity as yes. Yes. So, here in fact that should be indicated by what? That should be designated by C. That may be small letter c or capital letter C, does not matter, both are in use globally, but yes is not used in different places, in many other places. In our context only we are using it. So, keep in mind that I am using C for specific heat capacity, you can understand it yes for your regime. Okay. So, here Q is amount of heat absorbed. If a body is cooling, and that may, at that condition that may be what amount of heat released, heat left. Yes. C is specific heat capacity, as I told you, you can place here yes also, and delta T is change in temperature, which can be denoted by T2 minus T1. T2 is final temperature, T1 is initial temperature. In fact, you can consider any. You can consider final temperature is T. You can consider T1 is the temperature of hot water and T2 is temperature of cold water. Anyway, you can consider, that depends on your consideration. Okay. So, it is heat capacity. Okay. Different substances have different heat capacity. Here two things are mentioned. One thing is specific heat capacity, that depends on the nature of the substance. Another one is what? That is change in temperature. Which one changes temperature faster? Yes. So, here heat capacity will be less in that substance which changes its temperature faster. Which changes its temperature later, that means the substance has more retaining capacity, can retain the heat for longer time. So, we will discuss, after that we will do one activity related with what that is experiment, and it is very interesting experiment, you can do easily. Here one thing, if you are given to heat two substances in equal amount in identical vessel by giving equal heat, it is very difficult task. How can you measure that really the heat given to the material is equal? So, here I have changed little bit. I am taking water in a beaker, and in that beaker I am placing two test tubes with materials, temperature of which we have to measure. So, when water will be heated, at that condition you can see here I am taking that apparatus. So, here is water in the beaker, and here are two test tubes. One test tube is with less amount of water, in which an alcohol thermometer is used, and another one is with more amount of water. Material is same. Both are water, but in different amount. At first, we will measure the temperature, okay, temperature of them before heating. So here you can see, I'm turning it towards me, that is about 25. You can see it. Is it 25? And here in that, just let me see. Yes, here it is also 25. Both the water that may be in less amount or more amount, temperature is what? Yes, that is 25 degrees Celsius. Okay, now I am going to heat it. Okay, students, I am going to lit the spirit lamp. So let it be heated. It is not necessary that we have to boil the water. Just heat it, and after that we will find the change in temperature. Okay, just take 5 minutes. Okay, friends, you can see that where there is less amount of water, their temperature is about 42 degrees Celsius. You can see it. When I am taking it water, the temperature may drop. Yes, 42. It is in the case of alcohol, and so not alcohol, sorry, in the case of less amount of water. And here in the case of more amount of water, you can see that here temperature is not exceeding 40 degrees Celsius. It is not so clear, so you have to see carefully. That is mercury. So it is not exceeding above 40. Mass of water is more here. Mass of water is less in another one. Yes. So here this amount of water has more capacity of absorbing heat. Yes, but temperature does not increase more. But in this case, temperature is increased more. It is one fact. Okay, friends. Now see here, I am taking two vessels, two test tubes of same amount of materials, but type of materials different. With that red bulb thermometer, that is different material than water. Yes, it is alcohol. So if I am heating alcohol directly on fire, then what will happen? It will burn, it may burn. Okay, so here temperature, what is the temperature? You can see as before, here it is about 25 degrees Celsius, and it is also about 25 degrees Celsius, both same. Yes, now I am keeping them in hot water. Let's see what happens. Already water is heated. Yes, so here it will not take long time. Okay, students, now we have to study the change in temperature. Both of them were at 25 degrees Celsius. Now see what is the temperature of that alcohol thermometer which is kept in alcohol. In fact, out is alcohol, inside it also alcohol, doesn't matter. So it is showing temperature of about 50 degrees Celsius. Is it clear? Yes? Okay, leave it. Now see another one. What is its temperature? Look here. What is temperature? About 60 degrees Celsius. In fact, both were heated by giving what? Same amount of heat. Yes. So here, in fact, here water has more capacity of absorbing heat than what? Alcohol. Alcohol has less capacity of absorbing heat. Yes. So what did we do? Just here it is written. You can remind once. Take a beaker with more than half water in it. Take two identical test tubes with different amount of water in them. Also adjust a thermometer in each of the test tubes. Record the temperature of both the thermometers. What did we got? Yes, we get what? 25 degrees Celsius. Heat the beaker for 5 minutes, that may be any time, using a spirit lamp or Bunsen burner. Find the difference in temperature and record them. We found that the temperature in less amount of water and more amount of water different. Yes, that is due to different what? Mass of the water, although they were same material. Yes, okay. Now take two identical test tubes. In second part we did one with water and other with kerosene, but in fact we used what? Alcohol. Yes, that was alcohol. In same volume, I measured them. Keep a thermometer in each of the test tubes as before. We did it. Record the temperature of both the thermometers. We found both 25 degrees Celsius because room temperature is that. Heat the beaker for 5 minutes using a spirit lamp or Bunsen burner. Find the difference in temperature and record them. And what did you find? Yes, water absorbed more amount of heat, but alcohol absorbed less amount of heat. Although both were given same amount of heat, because both of them were kept in the same water which was heating. So water's temperature was same. That was providing same heat. Yes? Okay, students. So analyze the observation and find the conclusion. So it is amount of matter that affects on change of temperature. It is nature of substance that affects in change of temperature, or you can say it is amount of substance which causes or which changes capacity of absorbing heat. It is nature of substance which causes the amount of absorbing heat. So two things about which we discussed, that Q equals C and into delta T. Yes, okay. Now here we found that heat absorbed is directly proportional to the mass of the body, or if mass is more, heat absorbed is more. If mass is less, heat absorbed is less. Yes? Okay, consider it is equation number 1. Now next thing we found that heat absorbed is directly proportional to change in temperature of a body. So according to the nature of that substance, there was different capacity of absorbing heat, and temperature was also different of alcohol and water, you remember. So that thing can be written in this way: Q is directly proportional to T2 minus T1, or you can say delta T. Delta T means same, T2 minus T1 or delta T, or you can say final temperature minus initial temperature. Okay. So it is equation number 2. And after combining these two equations, we find that Q is proportional to mass into delta T, that is heat capacity. If we are removing the sign proportion and keeping equal, then a constant number is required, constant value is required. You know it? Yes. So here this constant value is C. As I told you, you can use capital C or small c, doesn't matter. Both are used as symbol of specific heat capacity. So here C is a specific heat capacity which is constant for a body. A substance has constant specific heat capacity that may differ from substance to substance. That is another thing. But for single substance, for a particular substance, value of C is constant. So that C is used here as constant. Yes. So now we have got what? Q equals mc dt delta T, a difference in temperature, or T2 minus T1 in bracket you can write. Yes. And it is called as heat equation. Students, keep in mind, it is called as what? Heat equation. So what is heat equation? Heat equation is an equation that shows relation between amount of heat gained or lost, mass of a substance, specific heat capacity of the substance, and difference in temperature of the substance. So the equation which shows the relation among them, that is called as what? Heat equation. So we have got heat equation in analysis of what? Specific heat capacity. Okay. So that is used in solving numerical problems, on the basis of which we will solve some numerical problems. Okay. Okay, students, now see about specific heat capacity. Specific heat capacity is very similar to heat capacity, only difference is that heat capacity is without mentioning amount of substance, not based on amount of substance. The substance may be of any mass. What heat is required to raise the temperature by 1 degree Celsius is heat capacity. But in specific heat capacity, what amount of heat is required to rise or to raise the temperature of 1 kg mass of that body by 1 degree Celsius. So 1 kg, that is particular mass. So here specific heat capacity is the amount of heat energy required to raise the temperature of 1 kg of a substance by 1 degree Celsius. Before it, there was not mass, mentioning mass in the case of heat capacity, yes, or Q equals mc delta T, yes, okay. And here Q is amount of heat absorbed, m is mass of the body, C is the specific heat capacity of the body, and delta T is change in temperature of the body. Yes, so that formula will be used to solve numerical problems, as I told you. So remember this formula. The SI unit of specific heat capacity is joule per kg degree Celsius. In fact, according to SI unit, what should be here? Kelvin. If you are writing joule per kg Kelvin, that is not mistake, but in practice we use degree centigrade or degree Celsius because there is no difference in change in temperature in these two units. Yes, okay. Now continue it. Here different substances have different specific heat capacities. As I told you, as we have studied, that alcohol and water has different capacity of absorbing heat. So different capacity of retaining heat also. Yes, that is different specific heat capacity. So some substances, specific heat capacity of some substances are given here. Look here, water 4200 joule per kg degree Celsius, okay. Ethyl alcohol 2400, kerosene oil 210, ice 2100, mercury 126, unit is same, joule per kg degree Celsius, like that. Aluminium 884 joule per kg degree Celsius, iron only 460, copper lesser than it 385, silver 236, gold 130. So here one thing you have to keep in mind, that those substances which have more specific heat capacity, they change their temperature slowly, gradually. They do not change their temperature fast. And those which have less specific heat capacity, they change their temperature faster. On the basis of it, number of events we have to discuss. So before that, we are going to do some numerical problems. A numerical problem is given here, that is an electric kettle has 2 kg of water in it. So here in question number 1 we are talking here, mass of water that is m is given 2 kg. We are neglecting the mass of kettle because in question also it is given that neglect the kettle, not only mass but temperature also will neglect. Initial temperature of water, that is T1 is how much? 20 degrees Celsius. And final temperature is also given, final temperature of water T2, 80 degrees Celsius. So here you can find out change in temperature. Okay, very simply also you can calculate 80 minus 20, that is 60 degrees Celsius. What is heat absorbed then? Heat absorbed, that is Q equals what? Yes. So we know what does heat equation give? Q equals mc delta T, or difference in temperature. So we have to find out Q. Mass is 2, specific heat capacity is 4200, and then what is difference in temperature? 80 minus 20, that is what? 60. Yes, multiply them. 2 2s are 4, 2 4s are 8, 2 0 into 60. That equals what? 1 2 3 0, 6 4s are 24, 2 remainder, 6 8s are 48, 48 and 2 50. That is what? Amount of heat is measured in what? Joule. So you can write in scientific notation 5.04 into 10 to the power 245 joule, same thing. So here thus the water absorbs 5 lakhs, okay, 50, 40, 0, 0 joule, yes, 5 lakhs 4,000 joule, or you can say it into kilojoule also, 504 kilojoule, same thing, heat to raise its temperature by 60 degrees Celsius. So, in last you have to write answer in one sentence with unit. That is very simple question. Okay. Now, we have to see another question. That question is, a bucket has 50 kg of water at 5 degrees Celsius in 5 degrees Celsius in it. Okay. And look here in that numerical, you read once the numerical, there are two water is at two different temperatures. That is, mass is not single. One is mass of cold water, another one is mass of hot water. 15 kg of mass of cold water, colder than that 90 degrees Celsius. Yes, when water at 90 degrees Celsius was mixed in it, so you have to find out amount of hot water, that is mass, m2 you have to find. Yes, okay. Now, on the basis of it, what is given here? Just see here, mass, that is question number 2, yeah, mass of cold water. Consider it is m1. You can consider any m1 O2, whatever you are writing at first. If you are writing cold water, that is m1. If you are writing hot water, that is m1. And all the related things with cold water will be mentioned with 1 if you are writing in this way. Okay. So, m1 is how much? What is the mass? 15 kg. And what is the temperature of cold water? Temperature of cold water, that is T1, is what is 5 degrees Celsius? Yes, 5 degrees Celsius. Now, temperature of hot water, the water which is mixed in it, that temperature of hot water, that is T2, we are considering is T2, not final temperature. T2 I am considering what? Temperature of hot water, that is 90 degrees Celsius. Yes, 90 degrees Celsius. And when they are mixed together, then final temperature becomes different. So, that is lesser than 90 and greater than 5. Yes, temperature, that is T I am considering, and it is 25 degrees Celsius. See in numerical, that is 25 degrees Celsius. And you have to find out mass of hot water, that is m2. What? It is the values, they are the values given in the numerical. And one thing you have to keep in mind, that if two bodies of different thermal condition, two bodies at different temperature are kept together, then hotter body loses heat, colder body gains heat. Already you have studied. And the amount of heat lost is equal to amount of heat gained. So, whatever heat is lost by the hotter body, that amount of heat will be taken by what? Colder body. You know it? Yeah. So, that thing will be applied here, and remember, this relation is called as principle of calorimetry. What does it call? Principle of calorimetry. That term is not given to you, that is why here I am giving this term, principle of what? Calorimetry. Yes. Now, we have, I am using directly, I am not going to do separate what is about hot water and cold water, just heat, that is colder one. So, heat gained equals heat lost. and you should know that both is equal to mc dt. Yes. So here m1 c, and here you will write T final temperature is that, initial temperature is that. So T minus T1, and in the case of heat loss, M2 times C times, here what will you do? Final temperature is that, initial temperature is that, but here this temperature is dropped to that. So maximum, from maximum, minimum is subtracted. So here will be what? T2 minus T. You must be very careful to identify that which one will be subtracted from which. Okay. Now place the value. M1 is 15, specific heat capacity is 4200, then T is how much? 25, T1 is 5, yes, equals M2 we don't know, we don't have, C 4200, T2 is how much? 90, and T is 25. Okay. This 4200 you can cross. You have to find out M2. Yes. So what will be obtained after subtracting 25 from 90? 90 minus 25. You can subtract it. 90 minus 25, what do you get? 5. And then here 8 minus 2, 65. So I am writing this side here. So can we write 65 M2 equals that remaining number M2? Yes. And 25 minus 20 minus 5, we get what? 20 times 15, or you can say 300. Now you have got M2 equals 300 upon 65. Calculate it. What will you get? Yes, 4.61 kg. So there, after that, finally you have to write that what is the amount of mass. Yes. So in this way you can do numerical. Okay students, here are some more numericals to which you have to try yourself. Okay, here third one and fourth one, they are taken from your book, slightly edited, that is not in number, only language. So you will try yourself by the help of your teacher. And one project work you have to do, that is make a list of advantages of a specific heat capacity in our daily life with short description of each. In next class, we will discuss some such advantages of a specific heat capacity in our daily life. Yeah. Now, whatever you have learnt, mainly we have discussed about heat capacity and specific heat capacity. So let's see question number 1. Here question is, which of following is specific heat capacity? Amount of heat required to heat anybody. Amount of heat required to change temperature of a body by 1 degree Celsius. Amount of heat required to change temperature of 1 kg of a body by 1 degree Celsius. Amount of heat required to heat anybody of 1 kg mass. In your thought? Yes, that is what? C1, amount of heat required to change temperature of 1 kg mass or 1 kg of a body by 1 degree Celsius. What is next one? Which of following is formula of heat capacity? Q equals C times delta T. Q equals C times M times delta T. Q equals C over delta T. Q equals M over C times delta T. Remember, you are asked that what is the which of the following is formula of heat capacity. Yes. So you may be confused here. It is not Q equals Cm delta T. It is only what? Q equals C delta T. For specific only, you will select next one, B1. Okay. Now next question is, which of following event is related with specific heat capacity? Mercury is used in barometers. Water freezes from up to down in a vessel. Water is used to cook food, or mercury is used in thermometers. Think once. Yes, so that is, what is the correct answer? Correct answer is mercury is used in thermometers because mercury has very less specific heat capacity. So immediate response is given by it. It does not take more time to show the temperature. If you are using water instead of mercury, forget other properties which are also required for using in thermometer. So, one factor is specific heat also, specific heat capacity also. If you are placing 1 minute the thermometer in your armpit used with mercury, instead of that, if it is used with water, then about half an hour will be taken. Yes, or more time will be taken, may not be half an hour, few more minutes, many times, because difference in specific heat capacity 140, 42,000, 4200. Now, which statement of following is true about specific heat capacity? Due to maximum specific heat capacity of water, waves are formed in ocean. Is it? Due to more specific heat capacity of sand, desert's night is very cold. Think once. Due to maximum specific heat capacity of water, convection currents are formed near oceans. Or, due to maximum specific heat capacity of water, tides occur in ocean. Everything happens, but which one of them is due to specific heat capacity, more specific heat capacity of water? That is C1, yes, because convection current is that forms land breeze and sea breeze, about which you have done in junior classes, and here also we will discuss in next class. Okay. Okay, so here are some questions to which you have to copy and answer them. After that, you have to show to your teacher. First one is define specific heat capacity. Very easily you can do it. Differentiate heat capacity of iron from specific heat capacity of iron in 2 points. So, definition, formula, yes. Any more? If you think maybe unit may be different. So, that thing you have to write. Next one is, what is heat equation? Derive heat equation on the basis of specific heat capacity of mercury is 140 joule per kg degree Celsius. Degree is missing, you have to add yourself. Yes. Now, next one, fourth one, describe any two uses of specific heat capacity in our daily life. Any two uses of specific heat capacity, that may be more or less. One you have finished. Yes. Others you have to think. Describe the role of specific heat capacity in followings. First one, water of ocean plays important role in weather of coast, means coastal region, bank of ocean. Next, water is used in hot water baths. Why so? You have to write. Mercury is used as thermometric liquid. So, on the reference of what you have to mention? Specific heat capacity. Maybe other properties suitable for using in thermometer, but you have to mention what? Specific heat capacity. Okay, students, that's all for today. The remaining things will be in next class. Bye.